All right, hello. So in this video, I'm going to go over a couple of three different general operations that we can do with lists. So there's no new syntax here, and we've actually done a lot of this kind of thing before, but these are just sort of going to be a way of particularly framing how we might want to think about working with data as we're starting to analyze and work with lists of information. So the goal of this video is really about introducing some vocabulary and some sort of standard patterns and structures that you'd be able to use when working with lists of data. And so then to give you some examples that you can then use to come back to those later in order to say, okay, well, this is how I do something, that I do that kind of thing, and you'll have an example to work off of. And we'll come back to some of these ideas in future modules of stuff. All right, so the three operations we're going to talk about are mapping, filtering, and reducing. So let's start with the first one. So, come on. There we go. So a mapping operation is going to be an operation that's going to basically take a list, and it's going to go through each element in that list and take that element and transform it in some way, make some change, some standardized kind of change to that element, and then produce a brand new list that contains the transformed versions of all those previous elements. So for example, this might be that we're going to take a bunch of numbers and we're going to maybe put them through a multiplication operation, a transformation. We're going to multiply them all by themselves, we're going to square them, and now produce a new list of squared values of all those numbers. Maybe we're going to take a bunch of strings and we can add, and we can maybe transform them all into uppercase versions of themselves, and then that will then produce a new list of all the words uppercased. But the idea is we're going to go through and come up with some transformation, some change I want to make to all the elements, and we're going to apply it to all those elements in order to produce a new list of changed versions of things. All right, so the way map works like this is we can define ourselves some kind of function that's going to do our transforming work. We don't necessarily have to define this as a function, but it tends to make things a little bit clearer about like what's the step that we're going through, and it'll come back and help us out later. So in this case, I might say that the transformation I'm going to do is I'm going to take a number n and I'm going to square it. I'm going to multiply it by itself. So that's going to basically take one. It's going to take one, convert it into one. 2 becomes 4, 3 becomes 9, 4 becomes 16, 5 becomes 25, and so forth. I apologize for the math example, but it's sort of what I got off the top of my head. So that's our transformation. So then what we're going to do is, in order to do this mapping, we're going to take our list of numbers, our initial set of values, and then we're going to go ahead and say, well, I need to now take those values, and we need to transform each one of them by passing them through this transforming function, and then take that result and put it inside of a new list. So we'll make ourselves our new list. We'll call it squares. It's going to be our new transformed list. And it's going to start out empty because there's nothing there to begin with. We're then going to go through all the values in our original list, in our numbers, and we're going to figure out what is the transformed version of that number. So I might say take the 1, transform it, square it, and that gives me now a transformed 1. And then I can take that transformed value and I'm basically going to slot it into my new list, into the first slot. So then I'm now add a 1 to my squares. We then go back around to the next loop. Our number is now 2. We're going to square 2, which gives us a transformed value of 4, and we're going to take that 4 and we're going to throw it into my list. We then go to the 3 as our number, square that, transformed value of 3 is 9, take that, add it to my list, my new squares list, and so forth. So that by the end, after we finish going through all this loop, we've added a new element to my new list that's going to be adding the transformed versions into every single element, into our new squares lists. We've taken the transformed versions of all our elements, we've appended them to our new list, so that now I have my new list that's ready to go. I have my list of squares. My list of numbers is still there, it's exactly the same, it hasn't been modified, but I now have this new list of squares, which is my new list of transformed elements. This is producing a mapping from one set of values to a sort of transformed version of that. So the idea is that the 1 maps to, it connects to, it leads to the 1, the 2 maps or leads to the 4, the 3 maps or leads to the 9, the 4 maps or leads to the 16, and the 5 maps or leads to the 25. This is using the mathematical definition of a mapping, but you can even just, if you want to think of it as like literally like we're following the map to say, well, how do I get from this side of this version of the things, what's the path I need to follow, or rather than my mapping is say, follow this particular path to get to some other version of those numbers, right? So it's almost like, you think it's sort of like, I'm following the treasure map, and that's my mapping work that I'm doing, is following the map, I guess, sure. Great, so that's sort of how this works with numbers. As another example, I want to show you how this might work with some strings, so we're doing the same kind of work. So again, we're going to use the exact same structure here, the same sort of process. So I'm going to define myself my transforming function. In this case, it's going to be taking some text, and it's going to return the transformed value version of that, which is going to be that text with an exclamation point added to the end of it, just using string concatenation. I can then take my initial list of greetings, right? There's strings. I'm then going to create my new transformed list of enthusiastic greetings, right? This is going to be my new empty list to hold all my transformed data, because I'm going to basically make that island that everyone's going to be going to. I'm then going to go through all my greetings. We'll call each one a phrase. Then for each one of those greetings, I'm going to pass it into this transformation function, save that transformed value, and then take that transformed value and append it to my new list. So that when I then print out the results, I get all my greetings with exclamation points at the end. If I modify my transformation a little bit, add more exclamation points, I can get more exclamation points at the end as we go. It's worth noting here that I'm breaking this up into very explicit individual steps, right? I've made this transform function, I'm calling the function and then saving that as a transformed value, and then appending that transformed value. That's a lot of work potentially for what's really a small mapping in this case. I could have basically skipped out this function, which is really just taking text and adding exclamation points, and I could have just said, let's just have my transformed version be the phrase plus the exclamation points, right? I could have sort of skipped the call function, just do that work directly there. I could have even skipped out the transformed part and just go ahead and said, let's just put the expression directly inside the append. So basically, I could do the exact same kind of mapping work without having to necessarily make all these steps explicit. That said, I highly recommend that you do think about saying, let's define my transforming function, think about what that function is, and then really have that here's my transformed version, and I'm appending my transformed version to this list, because it helps clarify what steps you're going through in each case, sort of each line of code, rather than this thing, which is doing 4 things at once, right? We're modifying values, we're appending values, and we're making this whole list, so we're getting this all together. Though again, this still produces the exact same results. So here's another version of a mapping operation. And so we're basically going to use the same kind of structure, but this is going to let us be able to do, we're going to also do some mapping now on a more complex list. So this is going to be a list of dictionaries. So this is basically a data table. In this case, I have a data table where because I've got my list of dictionaries, and each dictionary has the same set of keys. We have a name and an age. And so basically I have a table of names and ages for 3 people, Ada, Sarah, and Zong. What I can do is I can now do a mapping operation, say, let's take this table and let's see if I can maybe map it into just a list of just the names. So almost a way of sort of thinking about extracting the column. Let me just get the list of names from there. And this is really a mapping operation, because I'm going to say I'm going to take a list of objects, but I want to transform that now into a list of names where I have a particular process. I'm going to say go through each row, each dictionary, and convert that dictionary into a single string that is that person's name. So that process, right, is that if I take in a person, and I'll get this a little bit later, if I take in a person dictionary, then what I'm interested in doing, my transformation, is to say, go to that person dictionary and grab the name, and that's the transformed value that I want to be able to then put inside my new list. So if I comment all this stuff out for just a second, right, if I could say print out people so we can see what the table looks like. Oh, sorry, run previous cell. So there's my table. If I then want to extract the name of the first element from people, that gives me just that first name. Once I've then got this, my transforming function, I can use the exact same structure, the same kind of algorithm, to be able to then see, in order to be able to actually do that mapping operation. So again, I'm going to create my new list for all my transformed elements. I'm going to go through my original list. So for each person in my original people list, I'm going to call my transforming function, passing in that particular value, which in this case is not a number or a string, but it's in fact an entire object, or I'm sorry, an entire dictionary. Take that dictionary, take that result, which happens to be a string, assign it to transformed, and then take that transformed value and append it into my new list. So that when I then print out my new list of just these sort of extracted values, I'm able to get just the names from my data table. We could do more to this as well. For example, if I wanted to make this extracting more complex, make a more complex transformation. For example, if I want to then capitalize all of these strings, I can do so, and that now gives me a capitalized mapping. That maps all these rows into capitalized strings. And we could be able to make more kinds of changes as part of the transformation function, right? But that's just modifying what we're transforming. The mapping operation itself, these 3 steps, right? Make your new list, loop through your list, and then, 4 steps, call your transformation, and then append your transformed version. that stuff is going to stay exactly the same no matter how complex my transformation gets or how complex my data ends up being. That's the core of this mapping kind of operation. All right, so in addition to mapping operations, we also then can have a filtering operation, which is going to work very, very similarly. It's going to have sort of a similar kind of structure. A filtering operation is going to be a way of going through our list and determining which values from the list we want to keep, that we want to go into our new filtered version of that list. So you can think about filtering. It's not so much that we're filtering out elements. We're trying to think, what should I get rid of from my list? As much as we're trying to think through, what should we keep? What's allowed to go through? A filtering operation is almost like a bouncer at the door for a bar, right? He's going to check to make sure that everyone who comes in no one's underage. You want to make sure that everyone who comes in is allowed to get in. So the filter here is the thing that says what's allowed to come through. You can think of it like the bouncer in a bar. You can think of it like a mesh on like a water filtration system, right? Where it's like we want to make sure only the water gets through, but the dirt gets stuck on the other end. Works with light as well. But the idea is filtering is keeping track through what do we want to let through. So we're going to use a similar kind of approach that we used with mapping. In this case, instead of defining a transforming function, right, a mapping operation, we're going to define ourselves a filtering function. A filtering function is going to, again, take in a value it's going to expect a value from our list. So in this case, we can represent a number. And what's going to do is instead of returning a transformed version of that value, it's going to return either true or false. True if the value is good and we should keep it and it should pass through our filter. It should get to the other side, right? It should get through the door. Or false if our bouncer needs to block that person, needs to keep them out of the bar. So in this case, we can filter for even values by having a function is even. It's going to return true if the numbers are even or false otherwise. We're going to do that by using our modulo divide by 2 operator. We covered this in a previous exercise / module, I believe. It's been a while now. So again, we're going to look at the remainder when divided by 2, and if that remainder is 0, then that means that there was no remainder, so we're going to return true. If that remainder is not 0, then that means that this expression will be false, so that's what we'll return. So in effect, this filter is going to say, if the value is even, return true, otherwise return false. Then what our filtering process looks like is we can then say, let's take our evens, and we're interested in filtering this list, right? That's going to be our new list of numbers. So we got our list of numbers, that's what we're going to filter. We then are going to create our new list. It's going to be our list of filtered values. We'll loop through all of our values in our original list, and then we'll check to see if they pass through the filter, right? If the result of this filtered number is true, then we go ahead and append them to the list, finally printing out the results when we're done. And so again, we can use the same kind of filtering process on more complex lists, for example. So we can use a similar kind of thing for figuring out if a person is literally old enough, taking our list of our table of people to figure out if they're old enough to, say, get into a bar or a show or something like that. They're over 18. So we can then we can do our work that says, okay, let's check to see if a person is old. We'll take in our person dict, and we'll check to see if that person's age is greater than 18 and return true or false, to return whether that is a true or false statement. We're then going to, again, do the same kind of thing. We're going to create our, not transform, but this is going to be our filtered list. Sorry, I'm trying to edit my code. We're going to take our filtered list. We'll have our new filtered list, old enough. We'll go through our original list. We'll see if they pass the filter, and if so, then we add them to my old enough list so that I can then print out who's old enough, and I can see that both Ada and Sarah are over 18, but Zong, who is only 17, didn't get through the filter, so he sort of ends up not being included. So again, this filter function, and sort of this is what the important point is that this filter function is very much about filtering for what things we want to keep rather than what things we want to throw out. And this is a really useful way of being able to figure out what is it that I want to, taking my list and trying to transform it down to something that's smaller and simpler for us to work with. It's worth noting, I don't have a slide on this, but it's worth noting that we can actually start combining these things together. So I can do, for example, I can say, take a list and we can do something like, here, we'll do it live, because I do live. So we've got our filtering list, right, is old enough. We can also put back in our extract name value for our person dict. I'll just type this real fast, which is going to return person dict name, capitalized, right? So this is our same code we had before. What we can then do is we can actually try to mix these things together. So I might say, like, all right, so my old enough, I'm interested in finding old enough names. What I might do is say, like, let's do my filtering work, right, for person people. If they're old enough, then I want to do my mapping. So I can then say, great, my transformed version of that is going to be taking my, will be my extract name for my person. And then what I'm going to do is inside that filter, I'm going to then append my transformed version. Oop. But that didn't quite work correctly. That's because I didn't actually finish changing all the values. And then what that will do is that, so again, now we're basically doing a filtering and a mapping at the same point, right? I'm going to say for each person, if we pass the filter, then do a mapping. If I went the other direction, I tried to map and then filter, then I'd have mapped that way their age, I would have lost it. So I need to sort of make sure the order of this matches. But this way I can basically start combining these two operations together so that I can start asking questions like, who's old enough to go to the show? Who's over 18? Well, the answer is Ada and Sarah, but I got the information by filtering information and then mapping it into the values that I actually cared about. All right, the last operation to talk about is reducing operation. And this is the most complicated for people to understand. It's the most complicated for people to totally understand. So while mapping is a transforming operation, so that's going to take our list and turn it into another list, a list of different transformed objects. Filtering is an operation that's going to take our list and figure out who should we keep and everyone else gets left behind. Reducing is an aggregation or combination operation. This is going to say take a list of values and we're going to smash them together. We're going to squeeze them down into a single, or combine them into a single actual value. It's called a reducing operation because we are reducing a list to a single value that we care about. Other language I've seen it called, I kind of called it a folding operation, where we're folding a list into itself, into a single thing. Summary operation, where we're going to summarize a list into a single value. But this is basically a reducing operation, is an aggregation. We're grouping a bunch of things together. All right, so how does this work? So we're going to define ourselves an reducing function, an aggregating function. And what this is going to do is, the idea is we're going to want to still go through all my items together, sort of one at a time, because we want to do that same kind of looping work that we've done previously. But what we're going to do is we're going to take each of those new values and we basically want to add it into sort of my current running total, my current aggregation. The thing that I think about whenever I'm doing this kind of work is I think about Play-Doh. I don't know if you've ever encountered like Play-Doh. It's like a child's toy where it's basically just a bunch of like dough that you can make work together. But if you imagine you've got like your ball of Play-Doh, you've got a bunch of strips of Play-Doh, right? You've got a list of different colored Play-Doh pieces, and you're trying to add them all together onto this Play-Doh ball. What the reducer function, this aggregation function you're defining, is going to say, well, given that I have a ball, a half-completed ball, how do I determine how to take this strip and add it onto my half-completed ball, which then makes my ball bigger? So we take that strip, we add onto my half-completed ball, makes it a little bit bigger. Right, my hands got a little bit bigger. We can take the next strip, add that onto my ball, which makes it a little bit bigger. Next one adds onto my ball, makes that a little bit bigger. So the idea is that we're going to keep creating a bigger and bigger ball by adding in one little piece at a time. And so that's what our function is going to do. So we're going to find ourselves a reducer function, which they're called reducers because they're going to do a reducing work. And what we're going to do is it's going to take in two arguments. So while my filtering and transforming functions only took in one argument, the value I was working with, my reducing operations are going to work with two values, because we need to work with both what's the new strip of Play-Doh that I'm playing with, but also what's the ball that I have so far? Where are they getting added onto? So that's going to take in what gets referred to as the accumulation, right? It's the combination of everything we've got so far. And then we'll also then take in that new value, that new strip of Play-Doh we want to put together. What we're then going to do is we're going to take my existing giant ball, my accumulation, and I'm going to do some work to combine it with the new value. So in this case, because I'm doing a string concatenation work, I'm trying to take a bunch of letters and link them together with arrows. I'm going to take my accumulation, I'm going to put an arrow after that, and then put the new value coming after it. So if my accumulation was A and my new value was a B, it's going to make my new accumulation will be an A arrow B, A-B effectively. I'm then going to make sure to return that new accumulation. So the idea is it's like I've got my thing that's helping me put my strips of Play-Doh onto the ball. I'm going to give them the ball and the strip of Play-Doh. They're going to put those things together and then hand it back to me so that I can then get the next strip and then hand them the ball and the strip and go together. This is basically like what my kid does when it's asking like, Dad, will you please help me? I'll be like, great, here's my thing, here's my new piece. Will you help me put this together? Hand it to me. I put it together and I hand the new thing back to them. They take that, the new piece, and they say, now will you help me put this one on? I take that and put that back together. We just keep going all along the way. All right, so that's what our reducing function looks like. how this works, we're going to take our initial list. In this case, we'll use a list of letters. I'm going to have an initial, I need something to start with, right? I need some kind of ball to begin putting letters on. This is usually going to be a sort of zero-ish kind of value. For a string, because I'm trying to accumulate some giant string, I'm going to start with an empty string, right? So this is basically the 0th of the string. It's a string that has no characters inside of it, right? So it's imagine like I'm starting with like not it's sort of a thing of Play-Doh, but it's like an empty thing of Play-Doh. There's like no Play-Doh. It's like the non-existence of Play-Doh. I'm then going to loop through all of my letters, and then for each one, I'm going to then take my current running total, my current giant ball of Play-Doh, take my little strip, and I'm going to link those things together. I'm going to hand them off to somebody else and say, hey, you combine these things together, and now give me that result back. They hand me the result back. I'm going to then reassign that to my link total. So they're basically going to say, like, I'm going to take my total accumulation, take it out of the box, give it to someone else. They're going to modify it, make it bigger, hand it back to me. I'm going to put it back inside that box. So then when the next thing comes along, I'll be able to take it back out of the box, hand it over, they make some changes, hands it back, I put it back in the box. So that I can go through this whole process so that I take my original initial string, which is nothing. I'm then going to link my initial string with an arrow, which is going to produce a dash. It's actually going to produce a dash A. There's an extra arrow here that I forgot. That'll dash my A, put a dash in front of my A. I can then be able to take my, right, so that becomes, so now I'll get a dash A kind of thing. I'm then going to take as my total link. I'm then going to take in the B. I link that together. That takes dash A dash B, links that together, puts those, I'll say, you know what, here, let me just show you how it looks. I'll go over to Jupyter. We'll go to this example in a second. Right, so that I end up saying take my dash A, I start with my empty string, add a dash to linking to A, take that aggregate, add a dash linking to B, take that accumulation, add a dash linking to C, now take that accumulation, add a dash linking to D, and then take that accumulation, add a dash linking to E, and that then produces the value that I was expecting the whole way through. And that's what a reducing operation, reducing function ends up looking like. So we can actually use this to do, so this works fine for if you're trying to think through, okay, well, how do I build up something? Or taking a list, I want to convert this into a string of some kind. We can do, what do I want to do with this? What was the next step? Right, so that's going to reduce our things into sort of a single list. I'll note there's a bunch of, that Python actually has a number of built-in reducing functions. So just like that there's a searching function that's like using the in operator, there's a bunch of built-in reducer functions as well. Let me move this out of the way so you can see something. So, for example, if I want to reduce a set of strings by saying I want to do this exact work, I want to take my accumulation, add some intermediate value, and then attach that new value to the end of it, you can actually use what's called a join operation, where I can take a string, which I want to be my separator, right? What's the thing that I want to use to connect a bunch of list elements to? And then I can call join and then say I want to use that thing to join all the elements from this list, and that will actually then build together the sort of the linked arrowed letter thing that I was looking for in the first place. You can use there's a sum function that you can use to figure out, to basically take all of your list of numbers and combine them all into a total by using your addition operator as your reducer. So imagine there's like an add function. That's our reducer function that we're working with, starting with 0. There's a maximum function that's going to figure out the max value of something. This is a little bit like finding the sort of a maximal value. This is going to basically go find the maximum of number. It's going to basically start with negative infinity as sort of my initial value, comparing each one as we go. So this is in this case, we're doing a sort of a kind of like this king of the hill search we talked about in a previous video. But in this case, we can have using that actually ends up being a reducer kind of function. I want to note that max and sum, that these things, max and sum in particular, only actually works with numbers. If you try to sum up a bunch of letters to say add them all together, it actually falls apart because you can't add a bunch of letters to 0, because again, we can't combine strings and numbers all together. Move this down. So I want to note that actually a lot of the kinds of things we've already done when working with lists and even with dictionaries are actually reducing kind of operations. So just like I said, finding the maximal value is actually a reducing operation, and we can think of it in that way. Doing other things are reducers as well. So for example, in a previous exercise, we did a letter counting process where we were trying to figure out the frequency of letters in a word. And we had some code that did that, right? So we, if you finish up the exercise, so that we might say, if I have my word like Mississippi, I can make a dictionary of counts, and then I can say, let's go through each letter in that word, get the current count, figure out if that's a 0 or a 1 or a 3 or whatever it is, add 1 to that current count, and then save that result back in my letter. we can actually sort of jig this a little bit as a reducer function or reducer operation following the same kind of structure that we did so far. So the way that we're going to do that is we're going to start by defining our reducer function. So in this case, let's call it count letter, because we're going to count an individual letter. We're going to take in the sort of the aggregation, the accumulation. So let's call this the accumulated counts. And then we're going to take in whatever the new letter is that we're working with. Then what we can do is we can do this exact kind of work. I'm going to actually cut and paste this. So what I can do is I can say, let's get the current count by, instead of looking at this thing called letter counts, we're going to look at my current accumulated counts. We're going to get the new letter value from there. So notice I'm not changing logic, I'm just changing variable names. And then my accumulated counts at whatever index that new letter is going to be equal to what now my current count plus 1, doing the same work. And then because it's a reducer function, we need to add one last step, which we then we need to return the new accumulation, right? We need to hand back the giant ball of Play-Doh. So we're going to then return my accumulated counts. So then what we can do is that inside my for loop, I can say, let's start my letter counts. For letter right, it's going to start out empty. For each letter in my word, I'm going to then say, let's go ahead and count the letter using my letter counts as the current accumulation, and then the letter as my new letter. So letter counts is going to get assigned to accumulated counts, and letter will get assigned to new letter. And then we're going to take the result of that, because it returns something, I need to assign a value to it. We're going to assign that back to my letter counts. So then I'm going to basically say, take my big ball of Play-Doh, take the little strip, combine them together by modifying that dictionary, and then take that and reassign it to my existing letter count, so we're basically able to go and we can keep running through this process again. And then if we print out the results in the end, we get the exact same thing, right? We haven't actually changed the results of our code, but what we've done is we've rethought through this process about thinking through, well, how am I accumulating? What am I doing at each individual step? And if you can think about what you do at each individual step of a loop, it often tends to be a little bit easier to think through the process. Because now I just think through, well, if I have a bunch of counts already, what do I want to do with the one new thing? Well, that's okay. I can figure out how to handle one new piece, return that accumulated work, and then I just have to do this exact same structure that's going to basically be almost like boilerplate, just like filling in the blanks, right? You're going to be, take your starting value is going to be equal to your reducer function, passing in your starting value and the new values as you go. So the idea here is that we have this standard pattern, this basic idea of how we can structure these kinds of operations. So if you can say, I have a list and I need to smash this down into one value, or I need to pull one value out, a single value out of it, or convert it into some single summary thing, you have a structure you can use to follow in order to do that kind of work. So again, mapping, filtering, reducing, these are all generic terms that are used across programming languages to ways to think about how to work with large amounts of data. And they're going to be similar to what we've done so far. And in fact, we've done a lot of this already, but it's a particular way we can think about using and talking about those operations. So that whenever you're confronted with a problem and you have a list and you need to do some work with it, you might think, am I changing every element in that list? Am I doing a mapping operation? In which case you can look at your sort of the mapping examples. You say, am I only keeping certain elements? Am I filtering for elements of that list? In which case, look at the filtering examples. Or you say, or am I combining? Am I reducing all those elements in a list to a single value? In which case, you can look at these reducer kinds of examples. So if you can identify what's the kind of thing you're doing, you can then use these patterns to help you more effectively and easily build out the kinds of code and do the kinds of data analysis work that you're interested in trying to do to answer your questions and solve your problems.